Okay, in this activity, we're going to look at some hypothetical commuting times, and we're going to see what the difference between the means, the sample sizes, and standard deviations, what effect that has on our inference procedures. Okay, so take a look at, imagine Alex. He has two routes that he could take to get to work or to get to school. Route 1 and Route 2, and then over 20 days, he randomly decides which days to go on which route, and he records how long it takes him to get to school. So notice that it's not that one route is always faster than the other route. However, it does look like one route tends to go faster than the other. In particular, look at Route 2. The data points, looks like there's more data points to the right for Route 2, and there's more data points to the left for Route 1. So let's test this using this two mean statistic test, inference procedure. Okay, so if we take that data and look at the summary statistics, it was 20 data points, right? 10 for Route 1, 10 for Route 2, so both of them had a sample size of 10. And if you calculate the mean for Route 1, it's 28. The mean for Route 2 is 32 minutes, okay? For both of them, it looked like the standard deviation was 6. And if you plug all of that into our guru, we get a p-value of 0.155. Okay, so notice with all of this, like our null hypothesis is that the mean time for Route 1 equals the mean time for Route 2. The null hypothesis is that there's no difference. The alternative hypothesis is just that there's no difference, okay? It just does not equal 0. So notice the question for E is this statistically significant? Our p-value was 0.155. It's like 15.5%, right? So because it's bigger than 0.1, bigger than 10%, that's not significant at any of the common significance levels. Usually we're looking for less than 10% to be like moderate evidence, less than 5% to be like, well, pretty strong evidence, and less than 1% to be, it's very strong evidence. But this is bigger than all of that, so it's not significant. If we calculated a 90% confidence interval using our guru, we would see that the intervals from negative 8.65 to 0.65. So 0 is inside that interval. The confidence interval includes 0. So what we're saying is we are 90% confident that 0 could be the difference in the population means. So it's entirely possible that there's no actual difference between the travel times. Okay, so our test kind of failed. We failed to reject the null hypothesis. Could be that they're the same. Let's take a look at some other values, okay? Suppose we got, Alex, Barb, Carl, and Donna, and they all collected data about their two different routes, okay? So Alex, we already kind of looked at his. Look at Barb's. Barb still has sample size 10 in each one of her populations, but the means look quite a bit different. Like Route 1 looks quite a bit less time than Route 2. So there the means look like they're different. Look at Carl's two values. He's also got sample size 10 for Route 1 and Route 2, but they're kind of mushed together. They're less variable. So the standard deviation is probably smaller for Carl. And look at Donna. Donna's two routes doesn't look very different. Like it's a little bit to the left for the first route, a little bit to the right for the second route, but she's got a much larger sample size. So let's take a look at those summary stats and see what we can conclude. So Barb, her sample size was 10, means were 25 versus 35. Sample standard deviation was 6, but her p-value was 0.0015 compared to Alex's 15%. So her p-value, there looks like it is statistically significant that the Route 1 is shorter than Route 2. Carl, he's got the same sample means that Alex had, same sample size, but his standard deviations were smaller, right? His data was more consistent. So his p-value was 0.008. So the difference between his travel times is significant at any of those standard significant levels, right? So Alex was 0.155, Carl is 0.008, so like less than 1%. Donna, her sample size was 40, but otherwise her means were the same as Alex's and her standard deviation was the same as Alex's. But because her sample size was bigger, her p-value is smaller than Alex's. His was 0.155, hers is 0.004, less than 1%. So what can we conclude? If you look on page 479, let's look at the roles of sample sizes, means, and standard deviation in these two sample t-tests, okay? As the difference in sample means increase, so that's like Barb's value, there's a bigger difference. The p-value gets smaller, decreases. As the sample standard deviations decrease, so look at Carl's compared to Alex's, p also decreases. And as the sample size increases, so looking at Donna's data, as sample size increase, p decreases. So in general, we want a small p-value. Small p-values allow us to reject the null hypothesis, right? So we want to have studies that have large sample sizes, or we want to design studies in such a way that we decrease variability. We want small standard deviations. If we have those things, that allows us to make stronger conclusions, right? Okay. In general, let's just kind of wrap up here. We extended our inference techniques to include comparing two means instead of just deciding what one mean was. We looked at the roles of sample size, means, and difference between the means and standard deviations or variability play in inference procedures. And we kind of reinforce that, we want small p-values. Notice also with confidence intervals, if our confidence interval contains 0, we fail to reject the null hypothesis. So you want a confidence interval that's completely away from 0. Also, in order to do any of this, you always need a random sample or random assignment into groups, right? That's one of our technical conditions. The other thing that we always need is either that the sample sizes are small. Either that the sample sizes are large enough, like bigger than 30, or if the sample sizes are small, then we're going to have to look at the raw data and judge to see is our data roughly normal? If both data sets are roughly normal, then this is all valid. And if it's not, and your sample sizes are small, this procedure is not really valid. There are, I think, 2 homework problems from this section that get into the validity, where you have to look at the normal probability plot to decide is my data roughly normal or not? Okay.